Okay, hello. I'm going to give you an overview of the CMS results for the Higgs boson decaying to vector bosons. In the introduction, with the run 2 concluded, LHC has delivered more than expected performance, and we have around 137 inverse femtobarn inverse of proton-proton data set at hand. Which actually provides a great opportunity to look further in the properties of the discovered Higgs boson at 125. With this kind of data set, and even before actually the full data set, the individual channels are becoming sensitive enough to measure various properties. So the coupling, signal strengths, fiducial and differential cross-sections, mass and width, and starting with the Higgs 2,4 leptons. So this is the analysis which is updated with the full run to luminosity. This channel, as you know, has a clean signature with 4 identified and isolated leptons, which has a high signal to branching ratio. In this analysis, in this version of the analysis, we provided the signal strengths in the stage 1.1 of the simplified template cross sections, and with this version, we also improved the binning, and some new variables were also introduced for the differential cross section. So you see here the 4 lepton invariant mass in the full range up to 500 GeV. You see the Higgs is still there, and the major irreducible background is di-Z production from standard model, and this is taken from simulation with corrections up to next to leading orders, and the Z plus X, which is the reducible background, is estimated using data-driven techniques from data. Okay, moving on. So these are the signal strengths for the stage 0. You can see that they are well compatible with the standard model expectation, and the inclusive signal strength we get is 0.94 with an error of plus minus 0.1. And then this is a 2D signal strength of the VBF VH production with the gluon fusion production, and we to extract the signal strengths, we use a 2D likelihood, which is constructed from the 4 lepton invariant mass and these kinematic distributions that we use in this analysis. So in total, with the stage 1.1 binning, we have 22 channels, and in 3 final states, so we have 66 channels in total. So this is the result of the stage 1.1 cross section. So you see here the expectation and the observation in various bins. It's not full 1.1. There has been some merging of the bins, which is driven by the statistical the availability of the statistics and the experimental sensitivity in those bins. You can find the binning structure in the backup, but here are all the bins. So it is so the gluon fusion 0 jet. In the PT Higgs is 0 to 10, 10 to 200, and then you have 1 jet and the 2 jet bins. Then you have some VBF-like bins in the gluon fusion, and then in the VBF category you have 1 jet and then you have also the VH hadronic and the leptonic. We have some spatial bins for the TTH as well in this analysis. So you see here the signal strengths for each of these categories, and they are within errors. They are compatible with standard model within the errors. For these measurements, the mass of the Higgs was profiled. So these are the fiducial cross sections. So a fiducial volume is defined to match closely the reconstruction level selection. And in this case, to minimize the model dependence, we a 1D 4 lepton unit mass has been fitted to extract the cross section, and this is the result. So you can see it's 2.73 with the statistical error and systematic are close by, and this is the theoretical cross section. So so these you can see are the various factors which goes into computation of this cross section, and the distributions here on the top is the fiducial cross section in every final state. So 2e to mu and for electron, and also the combination, and they are compared with the POHAG, which is hard to see, and also the NNLOPS, and they are matching within with the observation. And this is the cross section for various center of mass energies. So in run 1 with 7 TeV, 8 TeV, and also at 13 TeV, and they are also matching within the errors with the standard model. So now with the differential cross section, so we have measured the cross section with respect to the PT Higgs, the rapidity, number of jets, and the leading jet PT with updated binning, and the unfolding is performed by including the response matrix in the likelihood, and it is repeated to access the model independence. The unfolding is repeated with different response matrices created by varying the relative fraction of the standard model production mode, and then we compare the predictions to POHAG and then LOPS. You can see here the 4 distributions with respect to PT Higgs, rapidity, number of jets, and the leading jet PT. The dominant systematics here are the experimental ones, and theoretical uncertainties are subdominant for now. Okay, moving to Higgs to gamma gamma. So this is a high resolution channel with the small branching ratio, and it provides an excellent energy resolution, which comes from our ecal, and we have dedicated boosted decision trees trained for the vertex finding, the photon identification, and also to have the probability of having the correct vertex for both the photons, and this version of the analysis is with the 2016 plus 2017 data, which corresponds to around 77 inverse femtobarn. And this is the stage 1 of the simplified template cross sections. So this analysis, because we didn't have enough statistics, was limited to gluon fusion and VBF categories, and the gluon fusion, the DGH categories are defined with cuts on the equivalent reconstruction quantities of the defined generator level variables. Then we have different BDTs for the gluon fusion, targeting the gluon fusion categories, and also for the VBF we have a separate boosted decision tree, which is called DiJet BDT. And also within the stage 1 there are some bins which are merged in order to get enough statistics. So this you can see here, the famous diphoton invariant mass plot weighted with S over S plus B, and in the bottom you see the background component subtracted plot. So this is the matrix of events which shows you the contribution of each event category in the simplified template cross section bins. So the colored scale here is the fraction of each category, which is basically the rows counted by each stage 1 process, which are the columns. So each row by definition sums to 100%. You see some empty bins which actually are removed because the entries were less than 0.5%. Similarly, you see the similar plot for 2017. Okay. So now we, in order to extract the signal strengths, we do 2 kinds of groupings. One is a 7, we call 7 parameter fit, which corresponds to the maximum granularity achievable while maintaining the uncertainties to almost 100% standard model prediction. So you see here the merging of the bins. So all the shaded areas are merged. So these 2 bins, BSM bins, are merged. These are merged, and then this whole thing was merged. And you see the signal strengths for the 7 bins, 7 bins. And in this, to extract this again, the the Higgs mass was profiled. Now, a more granular binning is also, a grouping is also tried, where we have 13 parameter fit. And here we only merged like few bins, and you see the signal strength for all the 13 categories, and they are also, some of them have quite big quite big error bars, which is mostly because of the low statistics. Okay, so this was the full result of Higgs to gamma gamma on 2016 as well, where we so the previous one was only the stage 1 cross section, and this one was providing all the couplings, etc. And the fiducial and then the differential cross sections. So so this is on 35.9 femtobarn. So you see the composition of the signal in all the categories that we have in Higgs to gamma gamma. The width at half maximum, and the S over S plus B. The untagged category, as expected, is dominated by gluon fusion, and it is defined using the spatial diphoton BDT. As I said, VBF tags use a separate dijet BDT to reduce the, which is trained against the gluon fusion 2 jets, to reduce the gluon fusion contamination. And we also had a dedicated TTH hadronic BDT with this, and these are the signal strands for various production modes. So this gives you an overview about the systematics in the Higgs to gamma gamma, and you see that important contributions are from both theoretical and experimental sources, where the photon identification and systematics related to photons are the most dominant ones. These are the couplings. So this is a 2D likelihood scan is performed for the fermionic and vector boson production modes. So you see the best fit is represented by the cross, and the red diamond is the standard model expectation, and we are within 1 sigma boundary. And here it's in the kappa framework. This is a distribution of the kappa F versus kappa V, and you again see the expectation and the observation match within 1 sigma boundary. So now, slightly changing the topic, we recently had a Higgs to tau tau anomalous coupling result, and then it was merged with the Higgs to 4 lepton result. And for the Higgs to tau tau channel, we analyzed 35.9 femtobarn, but then it was combined with the Higgs to 4 lepton, which was around 18 femtobarn, and then it was for the final results, it was also combined with the run 1. And this is about the anomalous couplings of Higgs to VV. So the kinematic distributions for the production modes and the decay products have been used. So both the analysis kind of followed the similar strategy, and the signal scattering amplitude for the spin 0 Higgs boson with the 2 spin 1 gas bosons is represented by this formula, where A1, A2 are the CP even interaction parameters, and A3 represents the CP ode. This HVV amplitude can be parameterized as fractional cross sections. So we put limits on these fractions and the relative phases. So these are the results of the combination of the tau tau and for lepton, and you see that the large confidence levels and large values of these fractions of these parameters are predominantly constrained by the Higgs to VV analysis, which is basically the red curves here, and the narrow region is mostly constrained by Higgs to tau tau. So when you combine the both, we get the best limits. So now just a quick overview of the Higgs to WW. So it's with the second highest branching ratio for Higgs at 125. This result is on 35.9 inverse femto1 of data. So here we have two well-identified leptons and a moderate MET. The analysis is divided into the number of, you can divide into the, depending on the number of leptons, and then the two leptons are mostly are then further divided into with that multiplicity, and then finally you have all these categories. So then on the slide, on the next slide, I have the signal strengths for all the categories that we have, and then also merged in terms of the production modes, and they are all compatible with the standard model. Okay, so I'm gonna skip this because I think the time is over. But in terms of summary, so Higgs physics is in precision measurement era. Most of the inclusive measurements are already systematically limited with partial run-2 data set. And Higgs to 4 lepton has been presented with full run-2. Other analysis, I didn't cover all other many other analysis which within this short time. You can hear about Higgs to gamma gamma in the TT bar associated production mode tomorrow in Marco Peruzzi's talk. And most of these analysis and all of and some new measurements are being updated with full run-2 luminosity. So stay tuned. Thank you.